Hello and welcome. In this video, we'll explore what a compiler is, how it works, and the different types of compilers used in programming. It's a fundamental concept, especially if you're interested in the world behind the code, how software actually gets made. We're going to break it all down step by step with examples along the way. Let's get started. So, you've written some code. Awesome! But how does that code run on a different operating system? That's where cross-compilers come in. They translate your code for different platforms. Imagine translating a book from English to Spanish, crucial for embedded systems like smart home devices. Write code on a computer, target an embedded device. Cross-compilers offer efficiency and flexibility. Next up, we have JIT compilation, a technique that optimizes code execution in real time. Unlike traditional compilers that translate all the code up front, JIT compilers do it on the fly during program execution. Imagine streaming a movie. You don't download the entire thing before you start watching, right? You stream it bit by bit. That's kind of how JIT compilation works. It analyzes your code as it runs, identifying frequently used sections and optimizing them for faster execution. This is where things get really interesting because JIT compilers can adapt to your program's behavior. They can even recompile sections of code on the fly if they detect a more efficient way to execute them. This dynamic optimization leads to performance gains, especially in languages like Java, which rely heavily on JIT compilation in their virtual machines. It's like having a translator who constantly refines their translation as you speak, making it smoother and more efficient. Chapter 3. Code Transformers, Source-to-Source Compilers. Let's talk about source-to-source compilers, the code transformers of the compiler world. These compilers translate source code from one programming language to another. Imagine a recipe in English, but you need it in French. A source-to-source compiler is like a bilingual friend translating it for you. You get the same recipe, just in a different language. This is useful for leveraging existing code bases in different languages. Instead of rewriting, use a source-to-source compiler to bridge the gap. For example, integrate a Python project with a C++ library. A source-to-source compiler helps integrate them seamlessly. It's like a universal translator for code, enabling code reuse and integration. Chapter 4. Efficiency Boost, Incremental Compilers. Time for another efficiency booster. Incremental compilers. These compilers are all about saving you time and effort during development. Imagine you're working on a large project, and you make a small change to a single file. Instead of recompiling the entire project from scratch, an incremental compiler swoops in and analyzes the changes. It only recompiles the parts of the code that were directly affected by your modifications, leaving the rest untouched. It's like having a smart editor that only re-evaluates the sentences you've changed in a document, instead of rereading the entire thing. This significantly speeds up the development process, especially in larger projects where compilation time can be substantial. Incremental compilers are like having a helpful assistant who keeps track of your changes and ensures that only the necessary parts of your code get recompiled. Chapter 5. Reverse engineering, the world of decompilers. Finally, let's dive into the fascinating world of decompilers, the reverse engineers of the compiler family. Unlike traditional compilers that translate high-level code into machine code, decompilers do the opposite. They take machine code, the language your computer understands, and try to translate it back into a more human-readable, high-level language. It's like taking a disassembled gadget and trying to figure out how to put it back together. Now, decompilation isn't a perfect process. It's often challenging to reconstruct the original source code with complete accuracy. However, it's still a valuable tool for several reasons. Security researchers use decompilers to analyze malware and understand how it works. Software developers might use them to recover lost source code or study the inner workings of proprietary software. It's like having a code detective on your side, helping you uncover the secrets hidden within machine code. Outro compilers, the unsung heroes of software. That wraps up our overview of compilers and their types. We hope this video clarified the concept for you. Compilers are essential tools in the software development process, acting as the bridge between human-readable code and the machine instructions that power our devices. From cross-compilers that enable cross-platform development to GT compilers that optimize code execution on the fly, each type plays a crucial role in shaping the software we use every day. If you have any questions, feel free to ask in the comments. Don't forget to like and subscribe for more tech content.